So the next problem talks about an A/B test. So an A/B test is just a kind of another name for for a lot of people in the data science community is another name for what we in biostatistics would just call a randomized trial. In other words, they have a treatment and control in the language that I like to use. And in this case, they have two advertising schemes and they randomize them. And the randomization it's a good thing. Randomization is one of the core principles of study design, and the idea is that you're going to balance unobserved covariates so that they're equally distributed between both groups. Hopefully that occurs, but you're making it highly likely to occur with the randomization. And then when you compare the two groups, they're hopefully comparable. If you didn't do that, if you didn't randomize, you might wind up with the case that whatever is driving people to prefer one, ad campaign versus the other or something like that, might be driving the differences. So, for example, if we're comparing two treatments in a medical randomized trial, the sicker patients might want to choose one treatment over another treatment. So if we didn't randomize, all the sicker patients would have gone to one, and all the healthier patients would have gone to another. And so we wouldn't be able to differentiate whether a treatment effect we saw was due to the treatment or just due to the fact that the sicker patients tended to gravitate toward one of the two treatments. So that's what randomization is for. It's a core principle of statistics. That's why it's used so widely. At any rate, in this case, we saw one treatment saw an average of 10 purchases per day. The other treatment saw 11 purchases per day. Both of them were monitored for 100 days. And then it just says assume a common standard deviation of 4. And then it says do a z-test of equivalence. Okay, so we're going to have to stretch our muscles a little bit on this one. So I'm kind of given a lot of information to help us kind of push us along the way, but this is a little bit non-standard. It's asking us to kind of draw in different parts of the class. So what we want to do is just calculate a z-statistic. So what we need so the obvious statistic is just the difference in the rate of purchases between the 2 days. Well, that's 10 minus 1, or negative 1 or 1, depending on which order you're subtracting. Okay, so let's just do this, where we define M1 as 10, M2 as 11, and the difference, let's see, is difference a defined? Yeah, diff's already a defined thing. How about diff with one F? Is 10 minus 11. Okay, now we need a standard deviation, a pooled standard deviation. Let's call it S sub p. We're assuming a common standard deviation, so that's equal to 4. And so the standard error, right, the standard error is going to be 4. Then if we borrow the way in which we develop the standard error for the two-group t-test with a common variance, then that would be square root 1 over 100 for the first group, plus 1 over 100 for the second group. Okay? And then we want to test whether or not the mean difference is 0 versus it's not 0. So my test statistic, my z-statistic, is going to be the difference divided by the standard error. We've subtracted off the hypothesized value, not diff, DIF with 1. We've subtracted off the hypothesized value, which is 0. So, if I'm trying to explain things a little bit better here, the hypothesized value is 0, which of course doesn't do anything, but that's the real value for z. Okay, so our z, how many standard errors away from 0 was our observed difference? It's negative 1.77 standard errors away from 0. We need to figure out how far that is, whether or not statistically significant. So why don't we do p norm of our z value, and that gives me 0.038. However, it doesn't say, so we're going to have to assume that we need to do a two-sided test. So let's do 2 times that. There's our answer. Let's plug that in. And then we do not reject. We would not. So, if I don't tell you, let's just assume that the type 1 error rate is 0.05. So we would not reject for that. Then we plug in 0 and submit. There we go. And, again, it's the same problem that I'm having for whatever the reason with my auto grading function there. So I'll try and figure that out. but hopefully that shouldn't be too bad. It's sort of an odd problem. The main trick in this problem is figuring out the variance. And it's just, if you go to the lecture videos, when we developed the two-group t-test with a constant variance, this is just using the same formula. So we're stretching a little bit here by applying it to rates, but hopefully you've gotten the idea that the way in which we executed the formula was it the estimate for the difference in the two means that we wanted to test hypotheses about. So the estimate minus the hypothesized values, so we're assuming they're the same under the null hypothesis, then divided by the standard error, where we did the standard error calculation assuming the two variances are equal for this particular problem because it told us to do that. And in fact, it even gave us the standard deviation. Okay,